Hi guys, it's Molly here. Today we're looking at exercise 5b and 5c from your essential text. The first thing we need to do, and this is from 5b, which is quite a short exercise, we want to look at the graph of y equals e to the power of x. We do it in exactly the same way as we did in 5a, only that now we have a graph with e for the y values at times. So for the value of -1, when we substitute -1 into the equation y equals e to the power of x, we get e to the power of -1, which is 1 on e, and we substitute 0 in, gives us 1, of course, because anything to the power of 0 is 1, and then to substitute 1 in, we get e. We use this when we do the transformations in exactly the same way as we did previously. Moving on to exercise 5c, we're asked to solve exponential equations there. We solve for x as per usual. This time they ask us to solve by inspection. 4 to the power of x equals 256, and what we need to do, we need to get the same base. Once we've got the same base, we can actually eliminate the base and say, well, what does x equal? In this case, x equals 4, because if 4 to the power of x equals 4 to the power of 4, well, x must be 4. Furthermore, if we have 3 to the power of x minus 1, let's put 81 as a base 3. That's 3 to the power of 4. Let's get rid of the bases, giving us x minus 1 equals 4. And then we can just solve to find x equals 5. 5 to the power of 2x minus 4, if that equals 25 to the power of negative x plus 2, let's write 25 as with a base of 5. That's 5 to the power of 2. We multiply everything at the top by the 2, the index 2, giving us 5 to the power of negative 2x plus 4. Then let's just take away or get rid of the 5s now that we have the same base, leaving us with 2x minus 4 equals negative 2x plus 4. Solve in the usual way, and we get x equals 2. So as long as it's the same base, you can just solve for x in the normal way. Let's continue solving for x, and let's try something a little bit more difficult. We've got 9 to the power of x equals 12 times 3 to the power of x minus 27. What I can do here, I can make 9 to the power of x equal 3 to the power of x to the power of 2. That is 9 to the power of x, but just written in a different way, so that now I have the two things with bases in the equation. I have 3, so I've got 3x to the power of 2 equals 12 times 3 to the power of x minus 2 minus 27. Let's make y equal 3 to the power of x. So now we end up with y squared equals 12y minus 27. That now looks more familiar. Let's rearrange that and look at that. We have a quadratic there that we can solve in the usual way by cross multiplication. Y minus 3 times y minus 9 equals 0. Null factor law it, and we get y equals 3 or 9. Now, a lot of people will stop right there because they'll say that they've solved for the pronumeral, but don't be fooled, because y actually has nothing to do with the original equation. We're trying to solve for x. We've just put the y in to make that easier. We now need to go back and see what 3 to the power of x equals. Y is 3 to the power of x. So 3 to the power of x equals 3. And 3 to the power of x equals 9. When 3 to the power of x equals 3, that's 3 to the power of x equals 3 to the power of 1. So x is 1. When 3 to the power of x equals 9, that's x equals 2, because 3 to the power of 2 equals 9. Or 3 to the power of 2 equals, well, 3 to the power of x equals 3 to the power of 2. Again, as long as the base is the same, we can just solve for x in the normal way. And that's all we need to know for exercise 5b and 5c.